Uh, Can you hear me now? All right, sorry about that. I switched over from Streamlabs OBS to regular OBS, and I guess I didn't have everything quite set up right yet. Thanks for your patience. Uh, Last week, I was working on getting my avatar to be able to throw a ball, and we got to the point where we could catch a ball. We would added a ball that was falling and falling, and if we moved our hand under it using hand tracking, we could catch it. And so that is what we're going to be continuing with today. The goal for today's dev stream is to be able to throw the ball, to add physics support so that when I catch the ball and I move my hands, then the ball itself gets flung up into the air. But before we do that, we're going to do some Live2D rigging. Because one problem that we did discover last time was the fact that the coordinate space I'd created in Live2D wasn't very consistent and wasn't very usable. That was why the ball had such inconsistent movement in the graphics I posted. I was originally going to do that off screen, but it occurred to me that I usually do my Live2D rigging off screen, so I don't think I've ever really shown how I do it. And so I thought that might be a nice thing to show for a change, get a little art in with this coding. And with that, here we have my avatar. So we go ahead and set the hands and ball to visible. And we look at our coordinate spaces here. Now, this whole thing from top to bottom is about about 3100 to... Oh wait, I'm looking at the wrong thing. X and Y. Okay, so 0, 0 is the top left corner. That simplifies things. Ooh, that looked kind of creepy, actually. Spooky. You can see all the meshes concentrate around the eyes and the other head items. Overkill, probably, but I'm not confident enough with the Live2D rigging to go in and cut that all down. So, on the bottom end, we have about 3,500 pixels by 5,000 pixels. So, I'll take down a note in there. Actually, I guess I'll show off the plan I've been making. I learned from Noella the other day that they've been using this planning software called Master Plan. And I thought it looked pretty good, so I adopted it as well and kind of put my plan for the whole juggling stream stuff in here. So here I kind of broke down the steps and pieces that we need to get done for this so we can see where we stand already. We got our basic loop here of reading the state, checking the ball position and calculating changes and then sending the state back. That's about half done. We've got the basic loop, we got the basic read, check, send implemented already. But we haven't implemented state saving or physics calculations yet. Over here I marked down some specifics we need to do for handling the interaction between the ball and the hands. Here is a re-rig project, which is what we're working on, what we're going to do right now. We're going to redo the Live2D parameters and rigging so that the ball and hands exist in a consistent space. That will make it mathematically much simpler to work with this. And down at the bottom here we have some other random things that I wanted to look into, but I'm not sure there's much we can specifically do about it. Okay, we pop that out of the way for now. And here we have it. The 3,500 times 5,000. I think the simplest way to do the math would just be to divide them by 10. So have 350 across and 500 vertical. That way one Live2D tick will be 10 pixels and we can easily work with that. I feel like I should back it up. I can start a whole new naming sense for this. Renpona, relayer, clock ball is a bit much. So, okay. Let's go in and edit the parameter settings. Ball, hand. So we'll start with the ball since it's nice and simple in some respects. Actually, no, I need more math, I think. I need to calculate the starting point. I need to decide the starting point in any case. No, that's a wild goose chase. That's a dead end there. I can calculate the starting point later. Right now I need most of all to have a consistent parameter space, a consistent coordinate space. From there I can do whatever the heck I need to do. And up. So let's see. Ball Y is the easy one here. So the minimum value will be 0. The maximum will be 500. And actually we want some negative space there so it can extend off the outside of the frame. So let's make this negative 100 and 600. With the understanding that 0 and 500 should be the actual boundaries. On the X side, we want to have our 0 in the middle. So that means we need to split our 350 in half. And have minus 175 and 175. And for now, we'll start with that. Yeah, I think so. And with that, we can change the parameters now for the ball. We have to unlink the X and Y so that we can do them separately. Oh yeah, it's this button. Oh, right. I have to select the object. And now, there we go. Delete that. Delete that. Delete that. Delete that. Okay, and this is X. Perfect. Now, let's see. We hit the add 3 keyforms to add keyforms on each side. This is a nice simple way of doing things. Oh geez, I'm gonna have to synthesize the corners again. At least this way it's pretty easy since there are fewer cases, so hopefully it won't be a big deal. Anyway, let's see. So, for -175, we'll want to put the ball over here. Put it center right on the edge, nice and simple. If we want the ball to go all the way up the screen, we can extend it a bit later. And now for +175, we do the same thing. And now with that, we have consistent left to right movement. And now the Y coordinate will get similar treatment. Delete all the existing keys. And that leaves us with just 0. Which we will go ahead and align with the exact bottom of the avatar frame. And now with that, we add another keyform at 500. And for that keyform, I want to zoom out a bit, drag this up, and put it about there. It doesn't need to be so perfect. Well, no. It kind of does. Let's line it up as close as we can at least. The more it's off, the trickier our math will be. That looks good. Now let's zoom way in down here, and that looks good already. Nailed it. And now we should have a consistent range of movement across here. And okay, if you go any higher than that, it disappears. I'm a bit surprised by that, but I'm not complaining. But I can't allow myself to be content by that. Okay, let's see. create a guide right at the bottom here. Add horizontal line. And now we'll move the guide. If I can remember which menu that's on. Guide settings. $4960. That looks like that guide. So we want to make that 5060. Exactly 100 pixels downward. And that would be this line right here. So now we can create another key format, -100. And place the ball there. That's not enough really. If that's the case, let's make it -200. That should be just about enough. And we move that appropriately. Now we just have to move that guide down another 100 pixels. Because I want to maintain the consistent math as much as we can. We'll delete that other guide that's nearby to reduce confusion. Up exactly. That's about as good as we're going to get. That's not completely off screen, but I don't want to say close enough, because if I say close enough, then I'll have to re-rig it again to change it. So, once more, let's bump that stuff down another 100 pixels. Why is it showing two guides there? Oh, I don't know, but it doesn't really matter. Well, add another 100 pixels here. And since we're learning this lesson, we'll go ahead and add 300 pixels to the other end of the spectrum. And down we go. No, wait, I messed something up. This isn't right. I guess I forgot to hit enter, or forgot to hit OK. In any case, it's fixed now. And we're set on the bottom half. And now clearly goes out of the frame. Now we can attack the top half, where we already had 100 pixels extra, so let's cut it down to 800. And once again, we do the same thing. We create a guide, add horizontal line, then we move that guide by entering new pixel values for it. Delete that other guide that's nearby, and that's simple enough. It was just 0 point, so we could have just done minus 300 from the start. Yes, I say minus because we are adding 300 pixels. Add a new parameter, 800. Voila. That. It should consistently cover. This doesn't feel right. Why doesn't it feel right? That should be 300. Let's see. So 10 points, 100 pixels. I think I screwed up my math. Let me see. I think I need to write it down just to get my head around it. So, 1,000 pixels equals 100 Live2D units. So 300 pixels should be 30 Live2D units, whereas I was reading it as 300. So yeah, that's my problem. I lost track of the units and have been rigging things for an order of magnitude. Good thing I caught that. Well, now that I know, it's an easy enough fix. So that should be 530, not 800, because we should be adding 30, not 300. Same thing here, we take out a 0. But we gotta re-rig the keyframes. It seems like it's touchy like that. I thought it would adjust them automatically, but I guess not. Zoom out here. Zoom in here. And there we go. Now that we've done that, we can cut some of the extra out of this and have the parameter range more accurately represent what we're doing. So 530. Okay, that's a bit easier to deal with. Okay, that feels right. We won't know for sure until we see it in action, but it feels right. Okay, so and our final result here, I'll note it down because apparently I need all the math help I can get. We go from -30 to 530 on Y. X is -175 to 175. This is important because we want to use the same numbers for the hands. That's part of this consistent coordinate space. But first, we link these parameters back up. And we gotta synthesize corners. But I don't really expect it to work that well. Oh yeah, that's terrible. But we gotta handle these corners manually. So this is here. So -175. Oh yeah, that's way off. You want this to be up here. As close to 0 as we can get it. And the upper corner should be up here. That's a bit off, so let's readjust. Alright. So that corner of things is set. Now we do the same thing for the other 4 corners. Seriously, synthesized corners is not keeping up with what I'm doing here. It's really a nice demonstration of how poorly suited it is for anything complicated. Not that I can complain too much. I'm doing the kind of stuff that isn't really meant to be done. And down here we should have similar complications. Yes, we do. So we do the same thing. You rig everything for the proper XY. It's actually a little bit off. Okay, that's good. How's that? Looks pretty good. Now we just gotta do the other corner. So we drag this down. Actually, that's pretty far off to begin with. Let's fix that up. Yeah. How's it looking on the other end? Oh, that was alright. It's got to start down there. And now on the other side, it's lined up well enough so we can relink and make sure we didn't screw anything up. Okay, so that's proper. And for this one, we gotta fix it again. Which isn't too hard. And now... there we go. It could be better. At the end of the day, we're ultimately eyeballing things, but still not bad. Yeah, everything feels consistent. It doesn't seem like the ball's jumping around weirdly anywhere. It's moving at a consistent rate. Awesome. And now we do the same for the hands. Right hand, left hand, we unlink. And these hands need to be completely re-rigged anyway. For one thing, they're not under a deformer. Don't know what the hell I was thinking, but that explains why I can't hide or show them. So each one needs to have a deformer. And the reason for a deformer is to separate the transformations of the mesh from the actual mesh itself. Having one mesh do multiple things tends to handle poorly because it's all being applied to the same thing. The changes tend to clash. Having a deformer there to warp the mesh without being the item that's without the mesh directly being warped allows better cooperation between different transformations. Think of it as a layer of abstraction for the meshes. But anyway, we create a deformer. We'll go with deformer. Now let's put the hand at the start. And we'll deformer and create. And you can see in the tree that test hand L is now inside the deformer. And that is basically how things run with this. And now we do the same thing with test hand R. These settings control how fine the deformer transformations can be, but we're not doing much in terms of mutating these, so we can leave it as it is. There'll be plenty of time to regret that later if it comes down to it. Now we've created our hands. And we can create the same parameter spread, so minus 175 to 175, minus 175 for X, 175 for X. On the Y side, the hands shouldn't ever go outside the frame. Probably anyway. So we'll just go with the standard 0 to 500. Honestly, even that's way too high. I'll try and clamp the value inside VTubeStudio, because we don't want the hands to have that free reign. Can we clamp the value in VTubeStudio? Okay, let's see. VTubeStudio. We'll look at the parameter settings real quick. Limit range. What happens if I limit the range? Just left hand. Okay, interesting. I don't remember what limit range does. But VTubeStudio is pretty well documented. Okay. I think that works. If it doesn't, I can come back and change it later. Because I just want the hands to move in a subset of this coordinate space, and I don't want to do the math to limit it on this end. I really should though. Makes no sense to have that much of a range. So, let's clear out some of our old guides. And I guess about the halfway point would be... Let's see. The bottom is 49.60. So the midpoint would be 24.8. Which we'll create manually. Okay, that's still pretty high, but acceptable. And with that, we can clamp the Y here to 250. 250 for the Y positions. Okie doke. Now we should be able to rig. For hands, the Y positions will have two keyforms. Bottom and top. For the X, we'll have 3. Okay, left hand deformer, X. Right hand deformer, X. We'll do the Y's in a minute since it's got other issues. Actually, no, let's get the hands in the right position first. So, hand left deformer. We'll hide the ball for now to get it out of the way. And there. And we will do the same with the right hand. Line it up the bottom line. There. Now that can be our Y 0 point. And back to what we were doing, we create our deformers for X. And yeah, we'll start with X. So left hand X minus 175 should go over here. This still isn't exactly. We line it up as exactly as reasonably possible. And now we just have to do the same here. There we go. Nope, wait, that's bad. We have the deformer. Okay. Deformer selected. We'll lock the hand meshes themselves to make sure we don't accidentally click them. Okay, and over on the other side of things. Where did our hand go? Alright, okay, it hasn't moved yet. We need to move it. That's how this works. Once again, we line it up against the corner. And that is our X-rigging. And we do the same thing for hand hour. First, just like in the other one, we have to readjust the position a little, recreate our keyforms. And now we mark the bottom of our coordinate space side to side. Still looks like it's a teeny bit off, but it's close enough for me. Alright, that's our X-rigging. Next up, we'll create Y rigging. Up, down, vertical. This time we'll do two keyforms, 0 to 250. And so we drag it up. Grid's kind of annoying now, so we'll remove it so that we can focus more on the guide. All right. Oh, except I screwed up. I didn't select the right keyform, so now we gotta do that again. With the keyform I actually wanted attached to this time. All right. Now that looks good. Still a little high for the hands, but it's my hope that we can tweak that in VTS. And now, hand right, same thing. Oh, I think I messed up here. Can I reverse the... Okay, as it's currently set, our hands will move the same direction. Should we reverse that in VTubeStudio or in here? We really should reverse it here. Let's see what the numbers reflect in VTS now. And left position X. So when it's on the left side from the avatar's perspective, the number is high. So hand left wants to have its high number here. And let's see with hand right. Hand right wants to have its high value there. So let's see, can we move the keyforms? We need to switch around right hand. Swap it. Minus 175. And let's see if that worked. It did not. I didn't really expect it to. There's probably a smarter way to do that, but I don't know Live2D that well. So we're just going to do it the silly way and redo the keyforms. So the high value should be over here. And the low value should be over here. All right, and there we have it. You know, the hands properly move on opposite sides like they should. All right, now we just have to link them and make sure the corners are taken care of. I'm not even going to bother synthesizing since you've already crafted guides and markers to make this easy. So just make sure that this and the other X corner also helps that we don't have very complicated rigging here. It had to be carefully planned, but the implementation is much simpler than I had before. And for the left hand, we do the same thing. Fix it up. And on this side as well. All right. No, the hands are rigged. And the ball is rigged. And now that the visibility is on the meshes and the movements is on the deformer, the visible parameters should actually work appropriately. Let's see. Is there anything else we need to do here before we export? Well, one thing I do want to see is how things line up with the ball in the hands. So if the hand is there and the ball is at the same amount, okay. So I have to account for the height of the part meshes a little more. I kind of expected that. I wish there were better measuring tools here in L2D. With the coordinate system, I can measure more accurately. So, test hand. R, you are R. How tall are you? Will you tell me? Honestly, I didn't really expect it to. It's not too big a deal. I can look in the texture atlas. Shouldn't show that on stream. Yeah, I can look at it later. Texture atlas is something you don't really want to show people because that is all the pieces of the avatar. If somebody gets a whole texture atlas, that would be enough to eventually take it for themselves. I mean, they still have to rig it, but that's where all the art is. All cut up and properly divided up. I think we're going to save it with a new name. Sounds good. And now with that, we can export it. That'll take a minute to load. Export, physics settings, user data file, display information, center, everything looks good as normal. As you can see, I've been doing a lot with the avatar. About time to move some more stuff into old versions, probably. Yeah. Let's make things complicated and overwrite the existing relay or clock ball, because then we can keep the same stuff. We want to overwrite the model3.json. I think that we do. That'll take a minute, and while we do that, I'm gonna take a to start a time. Oh, I don't know what's wrong with the clock. Could it be that I didn't rig it on this model even though the clock is still there? Well, whatever. In any case, I will be back in 3 minutes. And we're back. Now that that's done, let's see. Layer, collect ball, model data, user data. Since I overwrote the Model 3, I probably need to set up the expressions again. So we open up Cubism Viewer, which is how we set up expressions in VTubeStudio. We bake them right into the Model 3 file. Yep. Well, luckily I've already done the expressions, so we just have to import them. Go ahead and grab everything, because why the hell not? Check them to make sure they work okay. Alright, everything checks out. Save, how do you save? Control S does it. Model3.json, on the right. And now we swap models for a second as we import the new one into VTubeStudio. Let's see. Folder. Oh, so one. All right. Menu. Close the viewer. And fire up the expressions working. Go ahead and hide my avatar for a second. And check my settings here. Did I pick the right avatar? And okay, that's a problem. I picked the wrong avatar. And back we are. Alright, let's see how this stuff works. Okay, everything's in a new position. The hands are faring poorly under the new tracking, but I kind of expected that they would. We need to set up... We need to adjust the parameters. So... hand left, hand right. Let's see. We want to change the caps here. Be at least 100 and let's say 30 there. Now, can raise it up. Okay, let's mark it 200. Alright. This gives us a decent range of motion, at least vertically. Still touchy, but I don't exactly have the greatest hand tracking setup. About as low as I can get it. I want to get it lower, so we'll mark this to 0. Okay, that seems acceptable. I can always tweak it more later. We do the same numbers for the right side. 200 to 0. And we also need to figure out the X values. Start with 150 to minus 150. I'm surprised the camera even picks up my hand this far over. Still, given the limited range, this is probably the best we can do. I'll bump it up a little more. We'll do 160. Nah, let's give it the full 175. It's pretty clear the hand tracking isn't utilizing the full range available anyway. And over here, we do the same. 75, negative 175. And good. Touchy, but well, that's all we can really expect from the VTS hand tracking. Which reminds me, I wanted to uncap the tracking there, so there's not much point in bumping it higher than that because my webcam only goes up to 30 FPS, but this should slightly increase the tracking performance anyway. I should also perk up the ball's range. Yeah, 530 minus 30. And no reason not to match it on this end right now. I might think of a reason later, but it's not really a concern right now. It's something I can tweak at any time. It's very easy. Maybe I'll even ask Denchi if he can advise me on this stuff. But for now, oh, these numbers look good. Yeah, it's still touchy, but that's the limit of webcam-based tracking. Still tracking my hands when it can find them. Alright. So now that we've done all of that, let's check that the API is running. It is. Okay. Anything odd happening in the log? Okay. Now, after all of that re-rigging, I hope you enjoyed the show and the peek in the Live2D side of all this wizardry. Now we can look at the actual programming. That actually did take a fair amount of time, though, and now we've still got to rejigger the numbers in here. So let's see. Okay. So we adjust to set our new upper and lower bounds on the Y side, at least. We adjust our maximums and minimums here for the custom parameters that we create. $30, $530. All right. Let's give it a test run and see if it's still working. Alright. It's slow. The ball's quite slow, which isn't that surprising. See if the collision detection still works. Let's stop it. Give it another run. And run it outside of debug mode, and okay, that's significantly faster. Probably the collision detection isn't going to work right now, but yeah. Okay, yeah, that's collision mechanics still have to be updated for the new speed. Okay, if the ball's within range of the hand. I'm not really thinking about these numbers, so they're probably wrong. You would think that I would think about the numbers I punch in. You would think that a programmer would do that. Head empty, no thoughts. Just make things move. Whatever. So we run it again. Is that enough of an update to the collision detection? Well, something's going wrong in an interesting fashion. Don't tell me I have to figure out what this code actually does. It's been a whole week. Okay. Right. Once we've expanded the coordinate space in general, we need to expand various margins pretty widely. Let's try this. Okay, something is wrong here. It's only doing the stopping when the ball hits the bottom. Now, why is that? Oh, so that's fine for the left hand. It's only the right hand that doesn't give a crap about. That's interesting. That smells like a typo somewhere. Somewhere I put something wrong. Oh, here it is. With right hand position Y, we're feeding in the value for the left hand. That explains the issues last time too. So we fix that. Okay. Give it another shot. Okay, it's catching it. It's not resting on top of the hand, but I didn't really expect it to. I haven't updated the values for the size of the hands in the new coordinate space, so it's just working off the hand center right now. Still, it's encouraging that it still works. Encouraging enough to come without some of this logging data. All right. At long last, we can move on to the next step. So now we want to, let's see, let's actually pull up our planning list and see what we managed to do. So, we re-rigged. And we'll add that to our list of done things. Alright, what else do we have? Let's see, on cap FPS, we're doing that now. Tweak the parameters, I want to tweak them more later. So the next thing we want to do, I think, is state tracking. So let's see. That's a bunch of red in. Oh, I don't know what that's about, and I don't care. So let's see. We read the physics params. then we return physics data. And maybe around there is where we want to save the physics data. And now we want to evaluate physics data. And then okay, let's see. What exactly do we want to track? We need to track the hand positions more so than the ball position. Well, do we need to track the ball position too? Yeah, we need to track momentum. The ball needs to remember, even after it leaves the hand, that it's been thrown. Okay, so thinking. Okay. I've got a starting point at least. After the new ball position is calculated. Okay. So we'll create a variable. And we'll log our physics data that we gather for each request in there. So this will be the old physics data that will be available when the next request comes through. Since that's global state, we don't have to worry too much about it. And as a result, we can check against it. Alright, so let's see. We want to check if the hand moved. Actually, we also want to check whether the ball is caught, don't we? And if that's the case, we also want to be able to check for multiple balls. In this case, the best way to do it would be an array, because we're going to have multiple balls later. If that's the case, it would be best for our balls to be 0 index and start from ball 0 to ball 1. But that's stuff we can figure out later. For now, we'll use a simple Boolean. Boolean, I guess. Pronunciation's hard. Okay. Yeah. This doesn't feel quite right. It feels like I should be able to make it cleverer and simpler. But part of that might just be me getting out of hand. It's easy to think that things could be simpler. It's a common trap for me to fall into, but this does seem like something where it's complicated in the first place, so it makes sense that logic would be complicated too. Okay. Well, right now it's not as if this caught variable actually does anything. Okay, so state. What exactly are we going to check against state? This takes some thinking because I'm trying to reverse engineer laws of physics, convert them into math. And I ain't no mathematician. Dang, my mouth tracking sucks. But that's neither here or there. It's funny that I do all this when I have such terrible rigging. But okay. Okay, what exactly do we have to check for state? I guess the main thing would be the hand out. The hand wise. To throw it, the hand's got to move upward. So. This is so sketchy. This is janky. I'll seriously have to see if I can get in touch with Denchi and have him help me improve the precision on this or something. I'm sure there's a lot I can do just from tweaking the parameters. But anyway. Let's see, let's add a new node here. Yeah. Might be best to have a stored acceleration somewhere that gets referenced to determine how much momentum the ball has, how fast it should be traveling. But that's kind of a next step right now. Our current step is just detecting if the hands are moving. If we can hurl this ball back upwards, that'll be my goal for this stream. Y is greater than physics state dot hand ly. So let's initialize physics state to null. Just something to make sure it's initialized properly and that we don't have any undefined errors. And we're working. Okay. If hand ly goes up, it goes up more than, let's say, 10 pixels. So if the hand's current height is noticeably higher than the store height, so that the difference is that. Based on the difference, we'll catapult the ball. Figure out the math for that in a bit. Also, we want to do this only if the ball is caught. So, we'll push this into a second if block. And RY, RY. That's the places that them to screw this up. Okay. So now we have that, and we have our collision here. Okay. Difference is we check the plans. 1 unit should be 10 pixels. 10 units should be 100 pixels. feel like the physics should be separate module or something. Well, part of the problem is I'm doing this ad hoc, so I haven't really planned it all out in the first place. So, let's see. How do this? We need to break this into some distinct operations. Basically, the stuff that overrides everything else. This needs to go first because it checks if the ball's already caught. We need a second state for thrown. Maybe? Yeah, we need to impart forces to the ball and then have a separate portion for actually turning those forces into action. Pixels, let's say 8 pixels. Well, no, let's say under pixels. Even that's not very much, though. And it is under pixels. Let's do 20. So if its only moves a little, we move the ball to the hand's new position to simulate carrying. If it moves a lot, we give an impulse to the ball to throw it upward. I don't know where the hell the clock stopped working. Oh, well. I can't worry about too much. I got other things going on, but I do once again have to step away for just a moment. So I'll see you folks in just a sec. Alright, and I'm back, and we're back to cover. And trying to remember what the heck I was doing. Some less dramatic music. That is a banger of a track right there. I love it. Anyway. We will copy this and we'll introduce the impulse calculation. Moving on from setting the ball directly to calculating a bunch of potential changes and then applying the final result at the end. That's kind of necessary to have the gravity processing working with everything else. Once I see how it actually works in action, I can adjust things. Seriously, what a good song. Even in the Mega Man series, which has a ton of good music, that is a standout for me. Now we get impulse here. Impulse there. I'm gonna get rid of caught mode if it's thrown. And put a cap on the impulse Y. Put a cap on how fast the ball can fall. Yeah. And we'll do the same thing with X, even though we're not using Impulse X yet. And if the ball is caught, remove all impulse. we move this calculation to determine whether it's fallen out of frame to after the impulse calculation, since that's where our gravity lives now. Do brackets there just for readability purposes. And for a game of what's wrong with this picture, there's gotta be something wrong. Okay, let's see. Does this stuff look right? It looks right-ish. Oh, nothing looks obviously wrong. Let's give it a shot. That is not the fun. That can not be. Oh. Because I mistook the variable name. Dynamic languages, how I hate to be. Okay, we're hooked up, but the ball ain't moving. Not moving at all. So, I guess we need to fire up the debugger again. Y is -20. Things the same. Ah, it's because I'm not feeding in the right data. I'm reading from a blank variable instead of reading from the parameter value we actually read. So next, that should do it. But it is not, in fact, doing it. So let's give it another debug. Ball Y, false Y. So, the hell? How did this thing get? Yeah. Wow. Why is it taking 0 minus 20 and reading it as 0.00-20? Dynamic languages. I'm definitely forcing this to be a number. No, I'm not. I think that's outputting a string. So let's see here. Okay, well, we're converting it through the number constructor for a reason. To remove the scientific notation that Unity is adding and VTubeStudio is reporting. To fixed. Returns a string. Parsing. Or parse float. This already gave us a hint. Number, parse float, not to fixed. Okay. But what we want is more like used as a function, number converts. So we wrap each of these in another number. I wonder if the double numbers are actually necessary. It's not something I really care enough to try and remove, though, so we'll stick with it. There we go. Let's go. Up. Okay, I wonder where it's failing. So you add a bunch of logging and try and suss out where it's going wrong. What's being reached versus not reached? Shit. Okay. So it did get into there. So it did detect when the hand was raised. Okay. But the increases we can actually provide are not big enough. Okay, let's give it another shot. We know it's getting caught, so we'll ignore that. I guess even +1 is 10 pixels. It's much more sensitive, and I'm using the old numbers still. Obviously, impulse to make it easier to tell. And let's give it another shot. I feel good about this one. Okay. So that did recognize a throw. You can see it jump up briefly. The problem is we're not tracking momentum yet. So it only moves upward for 1 frame before gravity reasserts itself and it drops. And I'll clear some breakpoints, we don't need them anymore. But if we're not caught, caught, momentum equals 0. Otherwise, this state. What's a state? What's the name of the state? I forgot already. physics state. That's what it is. So we add a variable for momentum and set to 0. And subtract ball y from the previous state. So if the ball was decreased, we'll get a negative number. If the ball was increased, we get a positive number. We'll move our gravity cap here. And we'll speed up gravity while we're at it. I think this should give us Y momentum. Let's give it a shot and see. Well, instead we broke something. What is going on? Why isn't it? Looks like it's stuck at -20 again. I guess here we add some more logging. Log momentum is and we'll log the impulse Y too, although I don't think that's what's going wrong. And close and restart. All right. Not a number. The fuck is not a number coming from? Where the hell is our non-number? Ball Y is definitely a number. Physics state dot ball Y. I'm baffled. Let's fire the debugger up again. What does it mean? Physics state. Well, that would do it. It should be ball 1Y here. That is more like it. touchy stuff going on in there. But this looks like other crap now. Let's see. All right, let's see. If minus 60. More. The hell even is that? That seems like old. How am I getting bogged down by old code already? Ah, jeez. Well, in any case, let's see, is there anything else? I feel like there should be something else. Something doesn't seem right. What am I missing? Oh, let's run it again like this and see. What the heck is happening there? Alright, let's log the ball position. If something's going wrong, you should see a very obvious jump. Okay, yeah. Getting a noticeable jump. Why is that? So we'll make a breakpoint here and have it only fire when position drop ball Y is greater than 500. And fire up that there debugger. Here, that one we don't need it anymore. again. Debug console is where this would be. I'm not getting anything useful. Alright, it's jumping because the ball offset changes. Okay. I know what I need to look for. I need to look at the momentum and see what kind of crazy numbers are coming out. Because the momentum is calculated from the ball position changing. So when the ball position changes, momentum makes a big jump. Okay, but what should I do about it? Let's see. Kind of get it. Momentum is calculated based on the ball position, so when the ball jumps from the bottom of the screen back to the top and wraps around, the momentum is read as very high positive. Easiest thing is to just zero the momentum when it comes out like that. But it's still not working. Let's see what it looks like now. Okay, I'm surprised it's not working. I'm surprised the impulse Y isn't giving us anything useful. So all numbers, or should be. Yeah, they definitely are. Thumb is greater than 100. By setting for the low value that resets. Does that fix the jump? Not really. Seems like it's gotten better, but I feel like the best thing would just be the drop impulse there. Drop momentum. Let's see what's going wrong. Catchy as hell, and why? Well, that's a distraction anyway. What I really want to do is see if we can throw the ball. Okay, the momentum dwindles too quickly. Let's reduce gravity. Reduce the acceleration of gravity anyway. Knock it way down. It should accumulate, but it's not. Why doesn't it? By all rights, it looks like it should be. Are we sending a request before we wait for the next one? We're only sending a request for a new list once we've confirmed the previous one's complete. So why is this? Pop into a debugger and see what these calculations actually look like. Momentum is 43. position. We go from 361 to 394. Part of the problem is that it's too hard to debug because the debugging messes everything up. Ball Y. The ball falls, then that should be negative. And it is. Why isn't it accumulating? We'll have to save state somewhere. I hoped I could avoid it because that's another thing to have to keep in track of manually. But if we can't calculate it, then there's no choice. I don't see why this calculation isn't working. Oh, that should help at least. Caught another typo. But that still doesn't change either of the behaviors I'm complaining about right now. Let's try this. Broaden the number of cases in which momentum is reset. That should hopefully help dial down that big jump upwards, but it's not. Go from 520 to 370 without hitting that. Let's create a breakpoint for if momentum is greater than 90. And start the debugger one more time. Get so damn high. All right, let's try it again. State.ball Y. I'm not learning anything useful from this. So, be useful. Oh, right, I forgot to put a forward. Oh, no, that's wrong. Okay, the momentum isn't working. Let's make momentum global, like I'd hope not to do, but it just doesn't seem like we have a choice. Wait. So we re-implement our gravity cap here. And you can probably get rid of this. Since this momentum is global, we now need to reduce it. Alright, let's give that a shot and see if it behaves any better. Acceleration, so the ball is still not behaving the way I want it to. The way in which I need add the impulse Y and momentum together probably needs to change. Okay, that seems like something. And let's log the momentum and see when it's not working the way it should be. Gathers too slowly and ramps up too quickly. still getting a jump at the bottom. We've at least freed ourselves from that. Nope. Still getting it. This is sketchy. At the rate this is going. Okay, we can at least eliminate the jump by doing this, I think. Then, oh, 0. Stop calculating momentum like this now. That looks like an improvement, I think. Well. Looks like we had something. Let's just catch this again. Alright, and on there. Okay, let's decrease the drop of momentum. It seems to have gone up too high at first and then faded away too fast afterward. Reduce our cap here. So our downward speed is capped there. I say cap, it's still higher than the cap because it's the wrong place. Stuff is getting added later, so let's try that again. Let's try the left hand, it tracks better. Cool. Touchy, but I've got it working. Very nice. Let's try it one more time and then kill it and see what the numbers say. I hate using my left hand for this. I prefer my right, but for some reason it's working better like this. Let's do that to something that's a little easier to figure out. Okay, let's try out these new numbers. I don't know why the right hand is so much more touchy. Oops, the hand tracking is touchy too. Knowing to recognize the throw. Again. Be good to me. Alright, that's very sketchy, it's very jank, but it's progress. I've just got to think of better math for ball moving. I want to have this doing percentages because that's easier to do in my head. It's weird. That's besides the point. What was I thinking? Oh, right, I was going to try out the percentages and see if it worked like that. Janky, but you can indeed throw a ball. Very, very nice. And that is our goal that we set. So let's see where we have here. So today we cleared this, cleared this, cleared this, cleared this, cleared this, cleared this, cleared this. So this was pretty much the entire to-do list for getting throwing working. It still does need some tweaking and fine-tuning, definitely for sure. But after that, we can hopefully move on to multiple balls, and I'm not even sure that's something to stream. I don't know. As much as I like code streams, there is something to be said for being able to figure stuff out at my own pace. Especially when stuff is acting jank like this. So with that, I think that might be a good place to end it for today. Thank you for coming, everyone. I hope you've enjoyed watching me do my coding streams. And I will be continuing on with another. Well, I don't know what I'm going to do next Friday since it's Thanksgiving weekend. We'll see. I'll decide during the week. Probably won't be anything big in any case. As for tomorrow, I will be playing the new factory management game, Factory Town. It just came out the other day, and I really like what I'm seeing with it. And so that is what I think I'm going to be doing tomorrow at 8 p.m. Eastern Standard Time. And for those of you who've been watching me on YouTube, thank you very much for coming. I hope you've enjoyed the show. For those of you on Twitch, also thank you for coming. I hope you enjoyed the show. And we will be, as usual, raiding. Let me just have a second to pick my target, and then we will move onward. Let's see. There's actually a fair few people on today. Skokie, there's Jusagi, there is Bellamy, there's Kaiten. Today I'm feeling like raiding Jusagi. I haven't seen them on in a while. So thank you for coming, and have a good night, everyone. I hope to see you tomorrow.